We are setting the live stream on YouTube. Just wait for a minute. Yeah. All right. So in the last lecture, so just revise within minute what we have seen in last lecture. Let's see. Yeah, in lecture 5, so we proved theorem 4. Yeah, if f is a mapping from A to B and x and y are subsets of A, then f of x intersection y is just subset of fx intersection fy. So there is no equality. So we proved this theorem, and then after that we have seen one counter example. See, and after that I have given you some homework. Yes, 3 examples I have given as homework for you. I hope you all have done these examples at home. Then after we have seen real valued functions, we define real valued function. See, then we have seen some operations on real valued functions. So addition, subtraction, multiplication, and division of real valued functions. After that, we have seen constant, how to multiply constant to function, or it is called scalar function. Yeah. After that, we have seen maximum and minimum. Definition of maximum function and minimum functions. What is maximum of two functions and what is minimum of two functions? After that, we have seen one formula, so which was well-known formula for real numbers, and we write this formula for mappings. So we write maximum of f and g as mod of f minus g plus f plus g divided by 2, and minimum of f and g. So f and g are mappings, real value mappings. Minimum of f and g equal to minus mod of f minus g plus f plus g divided by 2. So up till this we have seen in last lecture, that is lecture number 5. So let us start next lecture, that is lecture 6. See, so next lecture 6. So today first we will define characteristic function, and then we will see certain properties of this function. So first definition, that is characteristic function. So it is a well-known function which is helpful in many situations in real analysis. So first we will define characteristic function. Just a minute. Yeah. So first we'll define characteristic function. Definition. So definition of characteristic function. If capital A is a subset of, suppose, X, then just a minute. If capital A is a subset of real numbers, see, then characteristic function of capital A denoted by, so this is notation for characteristic function chi to suffix A. This is notation for characteristic function of capital A. So this is denoted by chi of A and it's defined by, as chi to suffix A, chi A of X, small x, will be equal to, so let us see, so that is equal to 1 if X is element of A, and that is equal to 0 if X is not element of A. So this is basic definition of characteristic function, that is chi of A. So if A is any subset of capital A, then what is characteristic function of A? It is denoted by first chi of A and it is defined as chi of A of X equal to 1 if X is element of A. If it is not element of A, then value of chi of A will be 0. See, so next, so you'll write it as a note. See, so first, what is characteristic function of empty set? See, the characteristic function of empty set is 0. So that will be first note, or as a remark you can write. And second, see, if capital A and capital B are equal sets, then what will be their characteristic function? Then see, chi of A will be equal to chi of B. Or you in reverse way also you can write. Also, see, if chi of A is equal to chi of B, then A will be equal to B. So chi of A equal to chi of B if and only if capital A equal to B. So these are two remarks. So next we will see different properties of this characteristic function. So next topic, that is properties of characteristic function. See, first property. So first I will just write and then we'll fruit these properties. So what is chi of A union B? Chi of A union B will be maximum of chi of A and chi of B. So that is first property. Second property, it will be chi of A intersection B. Chi of A intersection B will be minimum of chi of A and chi of B. Second property. What is third property? See, chi of A minus B will be equal to, it is chi of A minus chi of B. Third property. What is fourth property? Chi of A complement will be equal to 1 minus chi of A. Fourth property. What is fifth property? Chi So if you consider universal set, if you define chi on universal set, then chi of u will write will be always 1. So here you will write u. So yeah, where capital U is an universal set. See, so this fifth property. What is sixth property? Just return that chi of phi means chi of empty set will be always 0. So it is there. So these six properties are there. So we'll prove one by one. See. So first we define here characteristic function, and then we listed some properties of this characteristic function. So we'll prove one by one. So proof of first property. What is that? So chi of A union B is equal to chi of maximum of chi of A and chi of B. So we'll consider here certain cases. Let's see. So case 1. So what is case 1? If X is element of A union B, then what happens? If X is element of A union B and if X is not element of A union B. So we'll consider these two cases. First case, if X is an element of A union B, then what happens? See, then see, what is chi of A union B of X will be equal to 1 by definition of characteristic function. See, as X is element of A union B, it is there, implies that X belongs to A or X belongs to B. So it is there. So it will imply, so if X is element of A, then chi of A of X will be 1. So that will imply chi of A of X will be equal to 1, or chi of A, sorry, chi of B of X will be equal to 1. So that will imply, let us see, either chi of X equal to 1 or chi of Bx equal to 1. So that will imply maximum of, see, chi of A and chi of B will be always 1, because one of these two is always 1. Either chi of A is 1 or chi of B is 1. So therefore the maximum will be 1. See, so what it gives? It gives that, see, hence it gives that already we have seen chi of A union B of X is 1. And here what we obtain? Maximum of chi of A and chi of B is 1. So it gives that, see, chi of A union B of X is equal to maximum of chi of Ax and chi of Bx, and which is 1. That is what we get, chi of A union B is equal to maximum of chi of A and chi of B. So if X is element of A union B, then we prove this property first. See. So what happens if X is not element of A union B? Then what happens? So next case, that is case 2. If X is not element of A union B, see, then what happens? Then surely, using definition of chi function, then see, chi of A union B of X will be equal to 0, because X is not element of A union B. So now, see, if X is not element of A union B, then what happens? That will imply X is not in their union. Implies that, what it implies that if X is not in union, it means that X is not in A as well as B. So it implies that X does not belongs to A and X also does not belongs to B because it is not in union. See, so what it implies that hence what do we get? Chi of A of X will be equal to 0 and chi of B of X equal to 0 because X is not in A as well as B. So that will imply, so it gives that see chi A is 0, chi B is 0. So it gives that what is minimum of chi A of X and chi B of X. So it will be 0 because both of them are 0. Hence, sorry, what I'm writing here. So therefore the maximum also will be 0 because both of them are 0. Hence, what we will get? Hence, see, chi of A union B, that is, hence if X not belongs to A union B, then see, chi of A union B of X will be equal to maximum of chi of A of X and chi of B of X. See, so it will give, that is, chi of A union B will be equal to maximum of chi of A and chi of B, and hence proof. So we proved this theorem, this property in both cases, that is if X is element of A union B and X is not element of A union B. So from above two cases, what we obtain? We obtain that, see, chi of A union B equal to maximum of chi of A and chi of B. So that is our first property. Proof of first property. So proof of second property. So what is our claim here? Our claim is that, see, chi of A intersection B is equal to minimum of chi of A and chi of B. So that is we have to prove. So again, here we will consider two cases. Case 1. What is case 1? If X is element of A union B, sorry, if X is element of A intersection B, then what happens? See, so in that case,